Okay, in this video we are going to divide complex numbers, and we're going to use the same complex number, or at least part of it. So we are going to divide 2 plus 3i by another complex number, 4 minus I. So you remember how when we did addition and then we did subtraction, we turned the subtraction into an addition problem? This is kind of the same thing. We're going to turn this division problem into a multiplication problem. And we have to know what to multiply it by. And we're going to multiply it by something called the complex conjugate. And so a complex conjugate, in this case I look at the denominator, complex number, which is 4 minus I, so its complex conjugate is 4 plus I. See how it's the same A and B, but I just changed the sign? So if I had a negative 2 minus I, its complex conjugate would be negative 2 plus I. If I had a 6 plus I, its complex conjugate would be 6 minus I. So all I'm doing is changing the sign in between them. Alright, so let's go ahead and get rid of those. Alright, so we have to multiply by the complex conjugate, and now we know what the complex conjugate is. So when we multiply by the complex conjugate, you simply make the denominator the complex conjugate and the numerator. And so when you when you multiply anything by a fraction where the top is the same as the bottom, that's the same thing as 1. So if I had 2 divided by 2, that's the same thing as 1. If I have x divided by x, that's the same thing as 1. If I have x plus 1 divided by x plus 1, that's the same thing as 1, because these cancel each other. So when I multiply by 1, I'm not changing the value of this at all, because you can multiply anything by 1 and not change the value. Alright, so now that we know we have to multiply by the complex conjugate, this looks like a fraction times a fraction, which is what it is. So you really have two multiplication problems. You have 2 plus 3i times 4 plus I, that's the numerator, and you have 4 minus I times 4 plus I, that's the denominator. Let's go ahead and multiply these together individually, and then we'll bring them back together and see where we are. Okay, so in the last video I multiplied with the box method, so I'm going to do this with the FOIL method instead. So 2 times 4, that's 8, and my outsides are 2 plus I, so that's plus 2I. My insides here are 3 times 4 is 12, so that's 12I, and my last 3I times I is 3I squared. Let's combine some like terms. So I have 8, 2I plus 12I, well that's 14I, and then by definition, remember, I squared is negative 1. I squared is negative 1. So I'm substituting that in there. Let's go ahead and see where that gives us. So I have 8 plus 14i. So 3 times negative 1, that's a minus 3. So now I can combine these like terms. So 8 minus 3 is 5. So I have 5 plus 14i. So that's going to end up being my numerator when I'm ready. So let's go ahead and multiply these two together, and let's use the box method for these, just so I'm demonstrating two different things. You can do it however you want, but I like to demonstrate different techniques, and so students that are familiar with this, that might be helpful. Okay, so when I use the box method for multiplying, the first binomial, 4 minus I, well there it is right in the top. The second binomial, 4 plus I, there it is along the side. So we just simply multiply each piece together and put it in the box. 4 times 4 is 16. 4 times negative I That's going to be a negative 4i. And then I do it this way. 4 times I, well, that's a positive 4i. And then the last one, negative I times I, so that's negative I squared. So let's see what we have here and add up like terms. We have a 16, we have a minus 4i, we have a plus 4i, and we have a minus I squared. So right away you can probably see that these middle terms cancel out. Right? I have a minus 4i and a plus 4i. So let's go ahead and take care of those. So I have 16 minus I squared. By definition, I squared is negative 1. So watch carefully how I substitute this. So I have 16 minus, but now I'm going to put in my negative 1. Negative 1. I squared is negative 1. Change back to a different color. Okay, so a minus times a minus is a positive. So this gives me 16 plus 1, which is 17. So that's the denominator. So let's go back up here at the top. So after I multiplied through, my numerator is 5 plus 14i. My denominator is 17. I am perfectly happy with this answer, but in the back of the book, let me erase a few things here. In the back of the book, they're going to show this in complex number form, so you have to know how to break that apart. So we can break that apart into 5 over 17 plus 14 17ths I. So that's also the answer. I'm fine with either one of them, but depending on the question, the back of the book might prefer this, or it might prefer that. So that's the end of dividing.